Okay, so far we have calculated out estimates for the mean and the population proportion by hand. Okay, but oftentimes when we're dealing with 600, 700, thousands of responses, obviously the tool we're going to use is Excel. Okay, now the book shows one way, but the way we've typically done this in this class, which I think makes a lot more sense, is out on Chapter 9, and once you go to Blackboard and go to Chapter 9, and under Chapter 9 you're going to see what's called an Estimator's Workbook Template. You guys see that? It's under Study Card All Chapters, Estimator's Workbook Template. You guys find that? I want you to open that up. Okay, in this workbook, you'll see that we have multiple worksheets, and each one of these worksheets is used for a specific purpose. Okay, the first one says Z estimate mean. If you recall, this is what we were using to estimate the mean by hand, Z estimate mean. So this is the one I'm going to use at this point in class to estimate the mean, and the one we're going to use to estimate the proportion is Z estimate proportion, which is the fourth one. Okay, don't worry about the other ones for now. But let's see how these work. Okay, the first one is Z estimate of a mean. On the left-hand side in column B is all the input data that I want to give it, and the results displayed on the right-hand side. So let's say that, and I'm just going to throw out a hypothetical here. Let's say I sampled 30 people. Let's say you guys, you 30. Oops. Actually, that's wrong. That should go in sample size. Let's say I sampled 30 people, and I found that the average calories intake for those 30 people was, let's say, 2,500 a day with a standard deviation of 20. It tells us with a 90% confidence level, our confidence interval estimate is 2,500 plus or minus 6.01. It gives me the LCL and the UCL. So basically all it's doing is cranking out that formula for you. You know what I mean? That you guys did by hand. Just so that we can see this in action, if I change the confidence level from 90% to 0.99, what's going to happen to that plus or minus 6.01? Just so that we can see this in action. It's going to get wider, right? 0.99, I need to be more confident. Sure, that's going to go up. If I check my sample size and it goes from 30 to 300, what's going to happen to that plus or minus 9.41? If I sample more, what's going to happen over there? It's going to do what? It's going to get smaller. So just look at that visually. So we can see, the kind of things that can happen as we change this. Okay, so that is the template we're going to use at the very end. But you think about it, we need to pull the data first. Okay, we need to pull the data first. So let us take a look at an example, and I'm going to go to Blackboard, and let's do your Chapter 9 homework. And it's under estimation of the mean material, and we're doing part 2 with Excel. And for all these, I didn't write this. Assume a population standard deviation of, let's say, 5. Okay. All right, let's do the third one. You'll do the other two for homework. It says, using the General Social Survey 2008 file, estimate the average number of hours, or TV hours, that a U.S. citizen spent watching TV last week with 90% confidence. Okay. So what we need is our data first. Let us go and find the data. So I'm going to go over here, so 90% confidence. Let me just write that so I don't forget it. And I'm going to go over here to Book Excel files. Under Book Excel files, you'll see a folder called General Social Survey, or GSS. Okay, and you guys recall we used this in Stat 301. This is a survey that the U.S. government does every year, looking at general social trends. So it just provides some data for us to use. So let's bring up GSS 2008.xls. And you'll see what's in there. Okay. It looks as if, you know, we have a bunch of data. Here's ID, there's age, there's gender, there's race, there's income, there's education. Now, the thing specifically that I want to look for is a value that we ask these people about how many hours they watch TV. It looks like it's in column AW. Okay, so the first person said, on average, they watch 8 hours of TV a day. Frank?
Which one did you open?
2008. Did you find it?
Yeah.
Okay. Is everyone there? Shall I wait while people catch up? So what do I need? This is my data. What do I need? What do I need to do with this data so I can estimate the average number of hours people spend watching TV? What do I need to do with this data? This is sample data, so what do I need? Think about that estimator workbook. What is the input that I need?
Sample mean.
Okay, the first thing I need is the sample mean. How can I get the sample mean? Give me one way I can get the sample mean. This is not new to us. Give me one way I can get the sample mean. Anyone? Marcus, you weren't even in Stat 301, so if you answer, you're going to shame everyone.
Well, I don't know that you actually want to do this, but you can just take the average.
Yeah. You shamed everyone, Marcus. Because they all had this. Maybe you did too. Man, I don't know.
Right.
Shy.
Shy? That's one thing we can do. Okay, Marcus is right. The one thing we can do is, if we think about it, we can just use the function. This is AW, right? If we go down to the bottom of AW, okay, we can say equal average, and we can say AW2 through AW 2024. And I don't think it comes out to exactly it. It comes out to, so I want more decimal places, it comes out to 2.98. Okay, 2.98. One way. What else? Yes?
Just click AW at the top and highlight the little column that tells you bottom of your screen.
Okay. It tells you the average, right? Okay, we can do that. What else? What other, that's fine, but it kind of does the same thing as this. What other method, though, did we learn in Stat 301? Any method. What else did we learn? What else can we do when we have a column of data that we want to summarize? Huh? Subtotal. I'll just stand here. I don't care. I'm here. Until someone answers this correctly, I'm here. Kylie?
Go to data and then data analysis
There you
and
go.
descriptive.
Let's do that, okay? And this has an advantage for a couple reasons. If we go to data, and we did this in Stat 301, data analysis, and under data analysis, there is descriptive statistics. And remember, this gives us a whole bunch of things at once. You recall? A whole bunch of things at once. So go to data analysis, descriptive statistics. Let's click OK. And it says, all right, what would you like me to describe? And I'm going to say, okay, my input range is from AW1 through AW 2024. I could have just highlighted the whole column, but I really didn't want to do that. So AW1 to AW 2024. It's grouped in a column, yes. There are labels in the first row. output options, I want a new worksheet ply. And then I'm going to check that summary statistics box down at the bottom. So click on summary statistics. You guys with me? You guys remember this? Click OK. And it gives me a table that has a lot of information. Okay, it gives me my mean, which we calculate out manually using Marcus's way and Lindsay's way. But what it really gives me that's important to me as well, so I can use that 2.98, but what else does it give me that is important that I need for that spreadsheet?
Sample size.
It gives me the sample size. Now, some people, you remember, there were, I don't know, 2,024 rows, right? But some people didn't answer us. They said, I'm not answering that. They left it blank, right? So what is our true sample size here? Where do we find that?
1,324.
Right, the count, right? 1324. So in the standard deviation, let's use the 2.65. I said to use 5, but let's use the 2.65 it gives me. So we'll call that the population standard deviation. Our sample size is 1324. And our X bar is what? 2.89. Let's go back to our Excel template. And we're going to go to Z estimate mean, plug in 2.89. Our population standard deviation is 2.65. And our sample size is 1324. And what did I want to do this at? What confidence level did I tell you guys to use?
90.
So 0.90. It tells us then our confidence interval estimate is 2.89 plus or minus 0.12 hours with an LCL of 2.77 and 3.01. So think about what we're saying here. We're saying that the average time that a person spends watching TV is somewhere between 2.77 hours and 3.01 hours. And how confident are we that it's in that range? How confident are we it's in that range? 90%. If I wanted to be more confident, what's going to happen? If I change the 90% to 99%, what's going to happen? My confidence interval is going to get bigger. It's going to tell me 2.89 plus or minus 20%, or 0.2. Okay? So we sampled. From that, we're able to make an inference about the whole population. I want you guys to do one because that didn't feel good. It didn't feel like many people followed along with me there. So here's what I'd like you to do. Okay? I would like you to do, let's see, let's go back to chapter 9. I would like you guys to do estimate the average number of hours a U.S. citizen's worked last week with 95% confidence. So we're going to go in that same file, that GSS 2008 file, and I want to do the same thing I just did, but now I'm going to look at hours, HRS. Okay, look at HRS. Okay, that's the number of hours that a person worked. Go ahead. Go ahead, Michael.
I don't know why my Excel, when I go to data, I don't have data analysis.
Okay.
And I was looking to see if I could add it, but I don't know why I don't have it.
Okay, so we're trying to estimate the average number of hours that United States citizens spend working a week, or worked last week. So in the GSS 2008, we took a sample of, it looks like, over 2,000 U.S. citizens, and some gave us a response and some did not. Okay, some left it blank. So we're going to look at column, in this case Q, that has hours, and we want to take the average, the sample size, and the standard deviation. The easiest tool to do that is to use data analysis descriptive statistics. So I'm going to go from Q1, whoops, actually I'm going to go to data analysis, descriptive statistics, and I'm going to highlight Q1 the whole way down to Q2000. the end of my data, which is 2024. I am going to say columns because my data is in columns. I need to check this labels in first row button because in the first row is a label. If I don't check that, it's going to say, hey, that's not numeric data. I can't do anything with it. So I need to tell it to ignore that label. I'm going to click on New Worksheet Ply. I'm going to click on Summary Statistics. I'm going to click OK. And it gives me a table with a bunch of information at once. It tells me the average number of hours is 42.00. It tells me 1,203 people provided a response to that. There's my sample size. And I'm going to use the sample standard deviation of 14.47. So all I need, and I think I told you what confidence level to do this at, 95%? That's all I need to do this. So if I go over to my z-estimate mean, my sample mean was 42.00. My standard deviation, let's just use the sample standard deviation, is 14.48. So 14.48. My sample size is down here. It says count. It's 1203. And I said 95% confidence. And now it's telling me I can estimate with 95% confidence that the average number of hours that U.S. citizens spend working a week is somewhere between 41.18 and 42.82. Pretty powerful, right? That's pretty precise estimate with only sampling, what, 1,200 people? That's pretty powerful stuff. That's all thanks to the central limit theorem. You guys could do that on your own then? Okay. The one I'd like you to do for homework then, because we did 2 out of the 3 of your homework problems, is I want you to estimate the age, average age of a U.S. citizen with 99% confidence in the GS 2008 data set, period. That's all you have to do is 1.
The average age.
The average age, yes. It's the age column. God bless you. Okay. Now, if we want to estimate a population proportion, think about what we need to do that. We have a formula. We need really 3 things for that as well. We need p hat, or the sample proportion. We need the sample size. And we need the confidence level. And it'll spit out everything else. So I've gone from the z-estimate mean worksheet to the z-estimate proportion worksheet in the same workbook that we're in. Nora, got a question? No? Okay. You guys with me? All right. So let's do one of these, okay? And you guys can help me with this. Did you guys see what I put on my book? Did I leave my book back there behind you, Logan? Yeah. Just pass my book up, please. Let's do one of these in your book. So this is the homework for part 2 with Excel. I'm giving you 10, 11, 12, and 13. Let's do number, let's see. Since it's Olympic time, let's do number 13. I love the Olympics, by the way.
The Olympics.
Yeah, my whole
Did you
February
watch the X
set.
Games over the weekend?
No.
Why not?
That's a counterculture mover.
Counterculture?
Yeah, I'm not part of that.
Do you realize that half of what's in the X Games is going to be in the Olympics though?
I know, it's really moved that way, isn't it?
Yeah.
Yeah,
Slow style, everything, big air.
I'm a classical
Not big
guy,
air.
though. Classical.
What do you
Like
what-
hockey, curling,
ice skating,
skeleton,
it sounds like
luge.
too.
What's that?
Would you watch ice skating?
Oh yeah.
Oh, jeez.
Biathlon, cross country skiing,
Shooting the gun.
ice skating.
Running and skiing for like 20 miles. Doing the same
That's a
thing.
tough sport.
I mean,
All right, let's do number 13, because I'm recording this, so let's not record that part. 9:13, statistical techniques play a vital role in helping advertisers determine how many viewers watch the shows they sponsor. Although several companies sample TV viewers to determine what shows they watch, the best known is the AC Nielsen firm. You guys ever heard of AC Nielsen? No? Okay. The Nielsen ratings are based on a random sample of approximately 5,000 of the 115 million households in the U.S. with at least one TV. This is in 2010. A meter attached to the TV in the selected household keeps track of when the TVs are turned on and what channels they are turned to. The data are sent to Nielsen's computers every night, from which the company computes the ratings, and sponsors can determine the number of viewers and the potential value of any commercials. The results from Sunday, February 14th, 2010, for the time slot following 9 to 9:30 p.m. have been recorded using the following codes. NBC would like to use the data to estimate how many of the households were tuned to its coverage of the Vancouver Winter Olympics. Okay, so we want to know how many, but to get to how many, we need to estimate the proportion first, okay? So let's take a look at the data. This is in a book file, so this is 913, XRO 913. So if we go over to here, and we go to Book Excel Files, and this is Chapter 9, and XR 09-13. I want you to open up that worksheet, workbook. Okay, and according to this, 1 meant the TV was tuned to ABC, 2 meant CBS, 3 meant Fox, 4 meant Vancouver Winter Olympics, and 5 meant they weren't watching TV or they're on some other cable channel. I want to estimate the percentage that we're watching the NBC Olympics, the Vancouver Olympics. Think about what I need to do this. Okay, think about what I need to do this. According to my estimator workbook, I need what? I need the sample proportion, I need the sample size, and I need the confidence level to do this. So once again, I'm going to ask you, how do I get the sample proportion or the sample size? How do I go from this to the sample proportion? Give me one way I can do that. Basically, what do I want to do, Logan?
Percentage of which show?
Yeah, number 4s, right? I want to figure out the number of these, the percentage of these were tuned to number 4. Give me a way to do that. So if you guys are tasked with this, you can do it.
Is it with the county formula?
I could do that, right? One way I could do this, if you guys recall, remember our count if way back? We could do that. We could say this. We could say, well, I'm just going to shortcut this, but let's say equal count if. And remember, the count if function does what? The count if function, you give it a range, and you tell it what you want it to count, right, Juan? So the range I want to count, Juan, looks like it goes from A2 down to, wow, we surveyed a lot, A5001. So A2 to A5001. And what do I want to count, Juan?
4.
The 4s. Okay. So of the 5,000 TVs, 1,319 were tuned to this station. How would I get p hat from there? How would I get the sample proportion from there? Logan?
You take that number of how many 5,000
Very good. I could just simply say equal C2 divided by 5,000. That's how many I sampled. And I get 26.38%. Right, Logan? How else can I do this? That's one way, Juan. I'm fine with that. That's fine if you want to do it that way. How else could I do this? How else could I count the totals pretty damn quickly without putting in a function? Logan?
Data analysis.
Okay, I could do data analysis. What else what other tool did we learn in Stat 301 that changed my life? Heard a whisper of it. The pivot table. You guys remember the pivot table? All we would need to do, watch this, is go up to Insert Pivot Table. Okay, it says where is the data? I'm going to tell it my data is A1 through A5001. Holy cow, that takes forever. I want to put my pivot table in a new worksheet. I click OK. And do you guys remember how to do this? How would I get the number of 1s, number 2s, number 3s, number 4s, number 5s? I could simply drag Show to the row fields here area, drag Show to the value fields here area, and I can see what? How many people said 1? How many people said 2? How many said 3? Oh, that's a sum. It says sum. What do we want to change that to? Not sum, but what? If we go down here to values, it says sum. Go to value field settings and change it to count. So once again, we see our 1319 said 4. Same as we came up when we did Juan's method. How do we get the percentage? 1319 divided by what, Juan? By 5,000. Any other way to get p-hat without even doing a calculation using this pivot table tool? Do you guys recall this?
You use a filter?
Not a filter. Remember it said sum and I changed it to count. What else could I do? Under that value field settings. Kylie?
Percentage of column total.
Sure. Instead of showing it as a count, go down to count of show and go to value field settings. And then instead of showing the value as a count, go to show value as and change the no calculation to percentage of grand total. Click OK. And now, boom, there's our p-hat. 26.38% of people said they were watching the Vancouver Olympics. That's our p-hat. Still not done with this, but that's how I get my p-hat, right? Let's go to the workbook. The workbook is looking for the following things. It wants my sample proportion, my p-hat, which is what? We just calculated out. 0.2638, yes? What's my sample size? 5,000. What did I want to know this at? 95% confidence? Is that what it was? You guys remember? All right, the hell with it, 95%. So I know 26% plus or minus 1%. Now that's not what NBC wanted. They didn't want the percentage. They said, we want to know the number of US households that are watching the Olympics. Because we want to go to advertisers and say, if you advertise on our station, this is how many households are going to see your ad and potentially buy your product, whatever it is. That's how they make money, yes? So how did I get the number? Number of US households. Lindsay?
By the percentage, by the total number of households.
There's 115 million households, Lindsay, right? So we know as a percentage, somewhere between 25% and 27% of them, right? So if we take that 25%, which is in E5, and multiply it by 115 million, whoops, 1, 2, 3, 1, 2, 3. Make that bigger so we can see it. And multiply the upper percentage by 115 million. Format it nicely with the commas. We know about how many people were watching the Olympics on February 14th, 2010 in the United States. Somewhere between how many million and how many million? somewhere between 28 million and 31 million people. On the low end, 28 million people. On the high end, 31 million people. So now, when I ask that advertiser for $400,000 for a 30-second spot, I can say, well, you're getting exposure to 28 million people at the very least, right? And did I have to sample thousands and thousands and thousands of households? How many households did Nielsen sample? Only 5,000. Which is a lot. But to a company like AC Nielsen, install the boxes, that data comes in every night, right? They sample, they survey it, boom, there it is. There's the analysis. Do you see how that's done? Yes? No? Come on, Michael. There's something wrong with this class today. You guys
Yeah,
like, probably getting beat in the hallway before you came in here. What happened? Is this hard? Is this difficult? Michael? We'll talk. No?
It's just the sheer cold. It's affecting our sponge brain.
That's in the outside. That's like, you gotta shut off.
I can just feel it seeping through the windows.
Yeah.
Maybe if they write more tickets, they'll get some money.
Well, here's the deal, okay? At this point, this is what, Tuesday, okay? So Thursday, we'll go over this. You know, we'll actually start reviewing for our next exam. No new material is going to be given. Thursday is going to be our next exam. But I'm going to pause this here.